Hello, ladies and gentlemen. Welcome back. Let's take a look at Chapter 2.1, Part 2. In this section, we're going to look at the standardized values and z-scores. You should be pretty familiar with this already because you did it in advanced algebra at the end of the year. All right, we may go into a little bit more detail with it. And also, I'm going to show you how you can use the calculator to do this. Some of you may prefer to use the table, but believe me, you're going to want to know how to use that calculator to save time because you don't want to always have to be looking at a piece of paper and trying to find that z-score on there. All right, here we go. So if x is an observation from a distribution that has known mean and standard deviation, the standard value of x is, okay, you should remember z equals x minus the mean divided by the standard deviation. Now, we're doing just the basics with this, and that's all we did in advanced algebra. As we go through the chapters and as we go through the year, this is going to change depending upon the situation. The formula is going to be the same, but there's going to be some things added to it. Okay, right now we're talking about means. In the future, we're going to talk about proportions, and then we're going to talk about sample sizes, and that's going to change. Our formula is going to modify a bit, but it's always going to be the x minus the mean divided by the standard deviation. Okay, more details of that later when we get to that stuff. All right, and again, the standardized value is often called the z-score. All right, so remember your empirical rule. All right, 68, 95, 99.7%. Now, remember the mean is always in the center of that normal curve. So when we standardize it, ladies and gentlemen, okay, when we standardize it, the mean would always be 0, okay, when we standardize it. No matter what the situation is, if we're talking about football, if we're talking about basketball, whatever, if we're doing something with normal curves, that mean, if we standardize it, if it's the mean, it will be 0 using that z-score. And then remember, we've got 1 to the right, 1 standard deviation to the right, 2 standard deviations to the right, 3 standard deviations to the right. Okay, going left, this would be -1, -2, and -3. Okay, those are the standardized values. And remember, 1 below to 1 above is 68%, 2 below to 2 above, 95%, 3 below to 3 above is that 99.7%. And you should have that whole normal curve memorized with all those little pieces in it. All right, so this is what I just showed you. Okay, the only thing I want to point out on this slide, ladies and gentlemen, and you want to add this to your notes, is this notation right here. Okay, this right here, ladies and gentlemen, that big N tells us that it's a normal distribution. Okay, so that big N tells us normal distribution with mu as the mean and sigma as the standard deviation. All right, so you may see that notation and you need to know what it means. Oh, that big N means it's normal. The first number is the mean, the second number is the standard deviation. Okay, it's kind of like an ordered pair, but it's not on the coordinate plane. It's the mean and the standard deviation. All right, let's keep rolling. So all we're going to do is we're going to go ahead and review the table quick, and then we'll do some practice. Well, let's do this first. Let's practice finding some z-scores first, then we'll go back to the table. So this piece of paper, I should say, this PDF, ladies and gentlemen, you do have access to this. I just want to point this out. I don't know if people actually want to print, but I did make a copy of it right here underneath the video. Okay, so you do have access to this if you want to print it or if you just want to go back and look at it. Nothing's filled in. Again, it's a PDF, and this is what I'm going to go over in this video. So you do have the option of printing that off if you want. Okay, so if you want, you can pause the video and print that if you've got a printer at home, and then take your notes on it. But that is up to you, okay? All right. Let's go. Oh, I also made available, ladies and gentlemen, I'll point this out since I have this screen up, that next to the textbook where your assignments are, next to the textbook right here, this normal curve, I made that available to you. It's a really nice picture. It's color. Okay, isn't that nice? Okay, so if you want to print that, go ahead. What I would advise you to do if you don't print it is I would download this and put it on your Chromebook somewhere so it's handy at all times. If you were in the classroom, I would give you this handout to have, all right? So there you will find, again, that's right next to the textbook, that's where you'll find that table. All right, let's keep going with this video. So, the standard normal calculations. In statistics, we like to compare things to see what or who is better. For example, what if we want to compare a football player with a basketball player, or a baseball player with a hockey player to see who is better, who is the better athlete? Or what if you want to compare SAT scores and ACT scores, exams to assess your knowledge for college? In sports, they have different stats for each, and the SAT and ACT are different exams. There is a solution to this problem, and that is called standardization. This means we can change the numbers, stats, scores, etc., so that they all have the same meaning or common scale. After we have changed them, we can then go through the process of comparing. Okay, but not today. We're not going to do the comparing today. We're just going to go ahead and find that z-score, and then we're going to use the table to find that area or proportion underneath that normal curve. All right, so I've already talked about this. Okay, there's our z equals x minus the mean divided by the standard deviation. All right, and I don't need to read that. So let's go ahead and look at our first example here. So we're just going to practice finding the z-score. All right, for a given population of high school seniors, the Scholastic Aptitude Test, SAT, in mathematics has a mean of 500. Okay, so it's telling us the mean is 500 with a standard deviation of 100. What is the z-score if a student made a 520 on the test? All right, so we need to go ahead and go z equals the 520, ladies and gentlemen, that is your x. So 520 minus the mean. Okay, obviously this answer should be positive because this person scored higher than the average, higher than the mean. All right, so that's going to go ahead and give us, oh, let's see, that would be 20 over 100, right? Okay, and then 20 divided by 100 is going to give us a decimal of 0.2. All right. Okay, let's move on. So the next one, again, remember the power of pause and rewind if I'm going too fast. So z equals, here's 495 minus the 500. Well, obviously this has got to be a negative z-score because it's that person scored below the average. All right, now I can figure that out, that is 5 over 100. And let's see, 5 divided by 100 is going to give us a 0.05. Now that 0 in front of the decimal is not necessary if you don't want to put it there. All right, let's just do one more of these. So this next one we've got, let me switch colors here. We've got 545 minus the 500 divided by the 100. Okay, well, again, I can do that top part in my head, right? 45 divided by 100. And if I type that in, I'm going to get 0.45. All right, and then that last one, pretty obvious, ladies and gentlemen. Z equals 473 minus the 500 divided by the 100. Okay, this is going to be below average because 473 minus 500, that person scored less than the mean. So that's going to be negative 27 over 100. So they're going to have a z-score of negative point. Oh, and I forgot something. Oh my goodness, I made a silly mistake, folks. This one up here is negative. Okay, my apologies on that. I hope you caught that and went, wait a minute, Mr. Ellering. Okay, that's supposed to be negative because it's below, and this is negative 0.27 for this one. So my apologies, silly mistake because I was trying to go too fast. All right, so watch out. If it's above the mean, you should have a positive z-score. If it's below the mean, you should have a negative z-score. All right, all right. So this is the same thing, okay? But in this one, we're going to go one step further. We're going to go ahead and find the proportion, which is the area underneath the curve. Remember, area, proportion, and probability are all going to mean the same thing here. All right? All right, so before we do that, let's go back to this slide for a moment. So again, we're going to be using that table, and I'm also going to show you at the end how we can use the calculator. Okay, I might actually do it before we get to the end of the video, but all right, let's see. Yep, so let's keep right on rolling, ladies and gentlemen. And let's go to the next step where we're going to find that area, also known as the proportion, also known as the probability underneath that curve. All right, so here we go. Let me move this down just a little bit further so I have an easier time of writing. All right, here we go. So in this situation, Z equals. All right, so let's see. For a given population of high school basketball players, the mean height is 73 inches and the standard deviation is 1.75. What proportion of high school basketball players are 6 feet tall or less? Okay, well, first let's convert 6 feet into inches, ladies and gentlemen, because the rest of the problem is given as inches, right? So that would be 6 feet would be 72 inches. So we're going to go ahead and take the 72 minus the mean, which is 73, and divide it by the 1.75. Okay, so let's see. That's going to be -1 divided by 1.75. Okay, and that's going to be negative. All right, now, when we're doing z-scores, we need to round to 2 decimal places. So this is going to be -0.57. The reason we want to round to 2 decimal places, ladies and gentlemen, is because that's what our table of values does. Our table of values rounds it to 2 significant digits, okay? All right. Before we actually go to the table, though, we should, ladies and gentlemen, draw this picture. All right, so just draw a simple normal curve. Zeros here. Okay, now -0.57. I'm going to say, okay, again, this is -1, this is -2, this is -3. All right, so -0.57 is going to be roughly, I'm going to say right about there. I'm going to mark that spot as -0.57. And I don't have a lot of room, but I should actually physically write that in there. Now, it says or less. So I'm going to go ahead and I'm going to shade this to the left. All right, because it's less. Now, this table of values, your Z table, ladies and gentlemen, table A, if you recall, the table gives all values to the left of that z-score. Okay, this is the negative side of the table. If I go to the next page, okay, that's the positive side of the table, but it still gives the area to the left of that z-score. Okay, that's the only values it will give. It does not give the values to the right of that z-score. It always gives it to the left. So you got to remember that important fact. So this is to the left, so I'm going to go ahead and look up -0.57. Okay, so I need to be on my negative side. So I'm going to go to 0, -0.5, which is right here, ladies and gentlemen. And then the 7, again, if I go too fast, rewind and watch this part again. Okay, that's going to be the third column from the end. All right, so I'm gonna go across, and I'm gonna go to right here, ladies and gentlemen, 0.2843. So that is the area to the left. All right, let me switch colors here. Again, that's 0.2843. So this is 0.2843. Okay, that's a 4, not a 9. Now, the answer to this question is 0.2843 are 6 feet or shorter. So out of all the basketball players, if we change that to a percent, that'd be roughly 28%, right? Roughly 28% of the basketball players are 6 feet or shorter. All right. Well, what about 6 feet or more? Okay, well, I don't need to do the Z table on that one again, or the Z score, because I already know what it is. I know what the 6 feet is, right? Okay, but now it's or more. So that means I would shade, I'm going to say that's the negative 0.57. I'm going to shade to the right. So remember, we got an extra step when you shade to the right, because again, that table of values only gives it to the left. So here you're going to do the 1 minus the 0.2843. Okay, and 1 minus the 0.2843, ladies and gentlemen, is going to be 0.7157. So that's telling us that, well, if we round it, if we could say roughly 72% are 6 feet or taller. Of all the basketball players, roughly 72%, not quite 72, okay, are 6 feet or taller. All right, if you didn't get that, rewind it, watch it again. Let's look at another one. Okay, I think I'm only going to do one more here because they're pretty repetitive as far as what we do. All right, so these are dealing with the same thing, okay? Okay, now this one, ladies and gentlemen, let's go to letter E. What proportion of high school basketball players are between 5 feet 10 inches and 6 feet 4 inches tall? Okay, well, first of all, I need to do the Z-score on both of those, all right? So I'm going to do the Z-score on both of those. So first of all, 5 feet 10 inches, ladies and gentlemen, that's 70. So I'm going to go 70 minus 72 divided by, what was it, 1.75. Let's just double check to make sure I don't mess that part up. Yep, 1.75 is the standard deviation. All right, so that would be -2 divided by the 1.75, and that's going to give us a Z value of -1.14. Remember, you got to go 2 decimal places. All right, and then the 6 feet 4 inches, well, 6 feet we know is 72 inches, and then another 4 inches, that's going to be 76. So this is going to be 76 minus 72 divided by 1.75. Okay, obviously that's going to be positive. That would be 4 divided by the 1.75, and we're going to get a Z-score of 2.29 if we round it appropriately. All right, okay. So I'm going to make my picture. All right, the negative, I'm just going to say this is -1.14 here, and I'm going to say the 2.29 is here. Okay, I'm going to shade between them. Now, when I do a between, I'm going to look up the big Z-score first in the table. So I got to go to positive 2.29. All right, positive 2.29. Well, here's positive 2.2. And 9 is the very last column, so that's going to be 0.9890. So I'm going to take 0.9890, and I'm going to subtract. Now I'm going to look up the negative 1.14. Now remember, that's going to give it to me to the left, but I don't want that. I want to cut that part of the table off. So negative 1.14. Let's see. The 4, ladies and gentlemen, is going to be the 1, 2, 3, 4, the fifth column. And the negative 0.11 right there. And I'm going to go over 1, 2, 3, 4 to the fifth column, which is right there. So 0.1271. 0.1271. Okay, so I'm cutting this part of the tail off because that 0.9890 goes all the way to the left, but I got to cut that off. So 0.9890 minus the 0.1271, and I find out that that area is 0.8619. So about 86% of the basketball players are 5 feet 10 inches to 6 feet 4 inches tall. So quite a few of them, roughly 86% of them, if we're talking about it as a percent. Now, let me show you with the calculator. All right, let me go back to the first part. Now again, use the power of rewind and pause on this if you need to. So I'm going to go back to this one right here. These two first. All right. So when we're using the calculator, ladies and gentlemen, okay, let me pull up a different screen here. All right. So calculator. We've got what is called a normal CDF. Okay. Now when we use this, the minimum Z value, or a low Z value, you could say low, goes first, and then the maximum or the high Z value goes there. Now, where is the normal CDF? Okay, you're going to hit the second button, and then you're going to hit the VARS button. Second VARS. Let me demonstrate. All right, clear this. I'll get rid of that. Okay, you're going to go second VARS, and it's number 2. We never use number 1. It's number 2. All right, let me do that again. Second VARS, number 2. Okay, now it says lower upper. So let's look at this, go back to this one right here. All right, in this situation, it's shaded. I'm looking at the red one, everybody. It's shaded to the left. So technically, there is no lower limit because that normal curve goes on forever to the left. So there is no lower limit. There is no low Z value. So we're just going to put a really small number, okay? So I'm going to go ahead and put negative 100 there. Or a negative 1,000. Sorry, I just typed too many zeros. Doesn't matter, just a really low number. And then the upper value, ladies and gentlemen, is going to be this Z-score that we found, negative 0.57. Okay, so I'm going to go negative 0.57. And again, that 0 is really not necessary. This mean should be a 0. This standard deviation should be a 1. Just leave those alone. Paste it, and then hit enter. 0.2843. Isn't that amazing, ladies and gentlemen? Look, that's exactly what we got right there, 0.2843. Isn't that cool? Calculator is way quicker than sitting there trying to look it up in the table. And this way, you don't need to worry about having to ever subtract from 1 like we do with the purple one. Let me demonstrate. So with the purple one, ladies and gentlemen, the negative 0.57, that is your low Z value. Okay, so let's go back to the calculator. I'm going to start that again. I'm going to go second VARS. I'm going to pick number 2. Okay, so my lower z value, again, is the negative 0.57 this time. So negative 0.57. And since it shades to the right, there is no upper bound. It goes on forever. I'm just going to pick a big number for my upper. I'm going to put 100. Please practice this at least several times so you get it down. And I paste it in, and voila, 0.71566. Okay, well, let's take a look. 0.7157. Wow, look at that. If we round it appropriately, that's what it is, 0.7157. Okay, and you didn't even have to worry about subtracting it from 1 because you didn't have to worry about only having shade to the left in the table. The calculator, you don't need to worry about that. Okay, let me do that last one, and I think this video is long enough because it's already past 25 minutes. All right, so this one is the between, right? So the minimum, this time the minimum, ladies and gentlemen, is the negative 1.14, and the maximum or the higher z value is 2.29. All right, so let's see if I can do this. Here we go. So again, number 2, never use number 1. So again, that lower z value is negative 1.14, so negative 1.14. My upper z value this time is the 2.29, 2.29. This is so much quicker than using that table. All right, leave the mean as 0 and the standard deviation as 1 because we're normalizing it, right? We normalized it already. Paste it and hit enter, and it's 0.8618. And look, ladies and gentlemen, there's a little bit of round off with this one, okay? The table, we rounded it to, I believe, a 9. The table rounds it to a 9, and here it's 0.8618. Not a big deal there. Okay, that one digit, it's 4 digits past the decimal. Being off by that 1 is not a big deal. All right. Hopefully that all made sense, ladies and gentlemen. So that's what the second part of the chapter is. All right. Okay, ladies and gentlemen, good luck. Make sure we'll work on the assignment in class, and then looking ahead, next week on the 6th, we'll do chapter 2.2, and on the 8th. And then our next test is on October 12th. Again, these chapters are pretty short. Most of the chapters only have maybe 2 sections. Some have 3, some have 4. All right, but we will have a test after each chapter. All right, good luck, ladies and gentlemen.